All right, so this is the lesson on the binomial theorem. And the binomial theorem is, again, this way of expanding a binomial. A binomial is two terms, x plus y, x squared plus 3. Those are all binomials. And we already have done a little bit of this. So it turns out that there's this thing that we've been doing, which is like x plus y squared. We did that back in Math 10C and 20-1. We saw that was x squared plus 2xy plus y squared. But what if we had x plus y to a different power, say n? Our goal is to figure out how this process works so that we can move through it a little bit more easily. So what we're going to do is we're going to use Pascal's triangle. So Pascal's triangle is named after a guy named Blaise Pascal, who's a Frenchman, and he came up with this really cool pattern. Now what I'm going to do is I'm going to write the next rows of Pascal's triangle. We went through this in class, so hopefully you can see the patterns. We'll go through the patterns here in a minute. All right, so what we're going to do is we're going to just write in the next row here. So this one, it would be 1, 5, 10, 10, 5, 1. Now you might be going, where are these numbers coming from? There is a really elegant pattern inherent in the triangle. And usually people start to see it as we go through. This one's going to be 1, 6, 15, 20, 15, 6, 1. Next up is going to be 1, 7, 21, 35, 35, 21, 7, 1. Now, with any luck, we're starting to get close to seeing it. What I want to do is I'm just going to point it out right now. This 7 comes from that 1 and that 6. Sorry to pause there and see if I could fix my my pen is going to the right place. This 21 comes from 6 and 15. This one here comes from the 15 and the 20, which makes the 35. Here we have another 15 and 20 makes 35. 15 and 6 makes 21, and 6 and 1 makes 7. So that's where all of those values are coming from in the in-between. So we've written the next two rows. Now, the reason that we care about this thing is that it correctly helps us spot the coefficients in the expansion. So if I did x plus y to the 0th power, well, anything to the 0th power is just 1. So that's just 1. If it's x plus y to the 1, now it's x plus y. X plus y squared is x squared plus 2xy plus y squared, and then so on and so forth. And again, these numbers exactly match the coefficients 1, 3, 3, 1. Now, those are, again, super useful patterns to note, but we wouldn't always do it this way. We wouldn't have to work through that. So, in this pattern, the things that we want to be able to spot are, there is always one more terms than the exponent. So if I was exponing x plus y to the n, there are always going to be n plus 1 terms. The sum of the exponents, x and y, in each term is always n. If you look up here at like x to the 5th, this is x to the 5th. Here we have 4 and 1, 3 and 2. They always add to 5. So that's a useful thing to note. The exponents on the x decrease from n down to 0. The exponents on the y increase from 0 to n. And the coefficients form this triangular array, or we would just say they are demonstrated from the Pascal's triangle. All right, so hopefully that makes sense. Now let's see the kinds of questions that we see here. It's also kind of cool to note that Pascal's triangle numbers, we don't have to make just by doing the whole thing. You can also look at them as being combinations. And so they form our work with NCR and all of those sorts of things gets played in and worked through those bits. So going back to here, let me just erase this. If I was going to expand a plus b to the 7th using Pascal's triangle, the very first thing I'm going to do is go through the entire triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. Now remember that my n, my exponent, is the n. And my n is always actually going to be given me by the second number in the row. So this is n equals 0. This is n equals 1 because of that. This is n equals 2 because of that. So you can always see the n. Go away. Go away. Or ooh away. That's fun too. Okay. So the second letter always, or second number always shows the n value. Row 4 is going to be 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. You can also see it's symmetrical. And eventually here 1, and give myself quite enough room. 35, 35, 21, 7, 1. So what this means is that those are my coefficients. My powers are always going to be 7. So my first thing is going to be 1a to the 7th. This next one is going to be this. So it's going to be plus 7, a to the 6th, b to the 1. Again, the sum of the exponents is always 7. The a values step down by 1, the b values step up by 1. 21, a to the 5, b 2, 35, a 4, b 3. And I'm kind of running out of space here, so I'm going to just move on down. This is now going to be 35. My a is gone 7, 6, 5, 4. I'm now on 3. B to the 2, sorry, not 2. I'm stepping up with the b's. So it was 3 up there. So it's now going to be 4. Before what, you might ask? That's the question. 21a squared b5, 7a1 b6, and plus 1b to the 7th. Now that's a lot of terms. Typically in tests and things, we don't ask for all of the terms. We just ask for a specific term. All right. This is the formula. It turns out that there's a really nice formula that does this, and that formula comes from the this equation. And again, it's just on your formula sheet here. And this is our piece. So we're going to use the binomial theorem to expand this. Well, we're going to figure out all of our terms. Again, typically we just do one. And in class I just did one, but here's all of them if you want. So I'm going to first do T1, then T2, then T3, then T4. Again, that just means the number of the term. How many terms is this going to have? Well, it's always one more than the exponent. So if my exponent is 5, that means that there will be 6 terms. So T5, T6. So T1, and now again, when you look at this, this is TK plus 1. k plus 1 is the term number. The k actually starts at 0. In this formula, by the way, I didn't really explain this all that effectively yet, but the n value is the exponent, and the k value is the counting number. I know that counting is not actually spelled with a k, but hopefully that helps you remember. So the k value is just a counting number. It just goes up by 1 each time, and it helps to make sure that our exponents are correct. So, if t1 equals tk plus 1, now I get another equation. 1 equals k plus 1. Subtract 1 from both sides, and I get k equals 0. We already know that the n is 5 because the question said so. So now I just go to the equation. nck, so that's going to be 5c0, and then x to the n minus k. Except my x isn't just x, it's 3a. Does that make sense? Hopefully. That's going to be the 5 minus 0, which is just 5. And then my y value, negative 4b to the 0. Now, technically, I don't even need that part because it's going to go away. Right? Anything to the 0th power is 1. And 5c0 is just 1. So this is going to be 1 times 3 to the 5th, a to the 5th, which is 243 a to the 5th. So that's going to be my first term of this thing. Whew, I definitely don't have enough room here, so I'm just going to try and minimize it as much as I can. If t of 2, t2, equals tk plus 1, that means that k is 1 now, because 1 plus 1 is 2. Or you could subtract 1 from your term number. So this is now plus 5c1, 3a to the 4th, and negative 4b to the 1. 5c1 is 5. And again, you can just push these numbers on your calculator. 3 to the 4th is 81, so 5 times 81. You know what? I'm not even going to trust my mental math on this. I'm just going to rock it right out on my calculator. So 5c1 times 3 to the 4th times negative 4. So that's negative 1620. A to the 4th, B to the 1. Next one's going to be my T3. Let's do this one in blue. This is going to be 5C2 now. 3A, you know what, this is just a nuisance here. 3A cubed negative 4B squared. So the powers just keep going up for the y's and down for the x's. 5c2, so now this is a handy calculator trick if you're doing these over and over again. Hit second enter, and it just gives it back to you. So now I can just go 5c2 times 3 cubed times, now I'm going to put my negative in brackets so that I can actually do this right. Squared. So that should be plus 430, or 4,320, sorry. A cubed B squared. And again, you can hopefully see the pattern here. We've only got a couple more terms to go, so let's keep going. We're halfway there. Woo! So T4 is going to be 5c3 now. My k value, k plus 1 is 4, then k is 3, times 3a squared, negative 4b cubed. Second enter. So I'm just going to change these values here, 5c3 to 3, negative 5760. A2, B3. Counting is apparently the hard part of figuring out. Next is going to be T5. I'm just going to write down here because I'm running out of space. 5C4, 3A to the 1, negative 4B to the 4th. Now again, second enter. 5C4, 3 to the 1, negative 4 to the 4, 380. What number? Red. I'll try and keep my color coordinating here so you can see which things go where. So plus 3840, A, B, 4. And then lastly, we need one more term, which is going to be T6. What color haven't I used here in a bit? Blue again. So T6 is going to be 5C5, 3A to the 0, and negative 4B to the 5th. So that's just 1. I just have to do negative 4 to the 5th. What is that going to be? 512 maybe? No, 256 I think. Here's hoping. Oh, 1020. I knew that. All right. So plus. Oh, minus, right? Because it'll actually be negative with an odd power. Minus 1024B to the 5th. So that's the entire expansion of that whole mess. Now, the sort of thing that we do much more often is we say, what is just this term? What is the third term in this expansion? So I know right away I'm going for T3. Why? Because the question says so. Now I just take the formula right off my formula sheet. You know what, I can scan up here. So this is that formula. Tk plus 1, nck, x to the n minus k, y to the k. You can keep referring to that in your own notes as you listen to me say it. I've used this so many times I don't need the formula anymore, I can just do it. So it's going to be, my n is 6. Let's actually do the whole thing here. So you go tk plus 1. And now we've got our little mini equation. K plus 1 equals 3, k equals 2. We already know our n. Our n is 6 because it's the exponent. So now this is going to be 6c2 times my a value to the 6 minus 2 and my b value to the k. So a, which is that whole bracket here, to the 6 minus 2, which is 4, and b, which is this whole thing here, all to the 2. Now we just push buttons on our calculator. So 6 math NC2 times 5 to the 4th times 2 squared is 37,500. And then it's going to be m to the 8. Does that make sense how I did all that? Again, you got to make sure you're distributing the exponent to both things. So maybe I should show that step a little more clearly to what I actually typed into my calculator. So 6c2 is 15. This is still going to be 5 to the 4th. This is m to the 8. Again, you multiply your exponents. And this is 2 squared. So that's all I did is I just put this out to the front. And then in my calculator, I typed in this times that. Hopefully that makes sense. Now, really, once you know your n and your k, you're done the work of the question. The hard part of the question is figuring out your n and your k. Once you've done that, the rest of the equation just works itself out. The equation does the work for you. On this thing, remember that our n is this. So my n is 7 right away before I've done anything else. Usually the term number tells us our k value, but in this case they didn't give us a term number. They just said contains x to the 5. Now, this question is specifically tricky because we get x's going in both places. And this is weird. So we get x's from the first part and x's from the second part, and that makes our life a little bit more difficult. There are two ways of doing this. The first way of doing this is that we use an algebraic approach. So I'm going to show you that right now. So I start off by writing out the equation. 7ck. Now the trouble is we don't know our k yet, so I'm going to leave it as just a variable. Now I have x cubed to the 7 minus k and negative 2 over x to the k. So that's just cutting and pasting the things from my equation onto here. Now, what I'm going to do is I'm going to go, this is, this is the part where you need to now just ignore all of the number parts. This one always throws people off. They're like, why can we do that? This is just like a side equation. I'm just going to pull this off to the side and do a little bit of busy work. Now, actually, I'm going to pull it off to the right side because I need more space for this. But this is kind of like the back of the napkin calculation before I can actually start the work of the question. So, what we're going to do is we're going to deal with just the exponent part, leave all numbers out. So this is going to be x cubed, that's still there, my variable part, to the 7 minus k. But I'm going to ignore the 7ck. That's just a number. It's not part of my variable. In this bracket, I'm going to ignore the negative 2. So I'm going to call this 1 over x to the k. Now I'm just going to do my multiplication here. So x cubed to the 7 minus k is going to become x cubed, just x to the 21 minus 3k. Right? So the 3 just distributes to both those places. And then this whole thing is divided by x to the k. Now think about it like this. You could even write 1 to the k if you wanted, although anything to 1 to the any power is still just 1. So let's maybe for clarity take that back off now. Boop. Go away. So what I'm going to do now is put these two pieces together. I'm going to like multiply my fractions. So I get x to the 21 minus 3k divided by x to the k. Now we want that to equal x to the 5th. And what I can now do is, now that I have the same base, I can combine my exponents on that. So when you have two things that have the same base and they're divided, that means we subtract the exponents. So this is going to be x to the 21 minus 4k, and it's going to equal x to the 5th. Whenever we have the same base and exponents in an equation, now we can just ignore the base and deal only with the exponents. Hopefully we remember that from our exponentials unit. So this, my exponent on the right side is just 5. Now I'm going to subtract 21. I get negative 4k equals negative 16. Divide by negative 4, divide by negative 4, and I get k equals positive 4. K should always be a whole number. 0 is the largest value you can have. It'll never be negative. It'll never be like 2.7. Now that we've done all that work, we can really start the question. And now that we've done that work, the question basically takes care of itself. So what I'm going to do here is I'm going to go 7c4 x cubed to the 7 minus 4 and negative 2 over x to the 4. So again, we dealt with just the x's till we found our k. Now that we found our k, we go back and do the whole thing. So this is going to be 7C4. You know what, let me show that step again. So math, number, probability. Put the number first. So 7C4. This is going to be what? That's 35. This is x cubed to the 3, or x to the 9th. And this is going to be -2. Remember, if you want to do this on your calculator, make sure you're using brackets. To the 4th, so that's positive 16. And then this becomes 35 times 16. 560. This is x to the 9th and x to the 4th, so it turned to x to the 5th, which is what we were hoping would happen. Woohoo! And again, these questions are uglier. Now, you can feel free to pause the video if you need to write all this down. I'm going to show you a different way of doing this. This is my favorite way of doing this. Algebraic is good, but that's a lot of work. There's a really elegant pattern that forms here. Whichever technique you like best, by the way, focus on. If you don't like the technique I'm going to show you next, don't worry too much about it. But what I'm going to do is I'm going to basically make a little table of values. N, or it's not even N, term. And x value. Okay? So what I'm going to do is I'm going to work this thing out. Imagine in my first term, it's going to be the a to the 5th. So in term 1, it's going to be x cubed, but not to the 5th, sorry, to the 7th, to my whole exponent. That's going to turn to x to the 21. In term 2, I'm going to have this to the 6th, and then this to the 1. And again, I'm just ignoring my number parts till I find my k. The first part of the question, no matter which way you shake it, is really just about finding your k. Well, this is going to be x to the 18 over x to the 1, which is x to the 17. If I do term 3, it's now going to be x cubed to the 5, and 1 over x squared, which is going to give me x to the 15 over x squared, which is x to the 13. Now, there's a really cool pattern happening here. 21, 17, 13. The next one should be 9. Yes, hopefully you see the pattern going down by 4. So let's try this. Term 4, x cubed to the 4th, 1 over x cubed. This is 12 over 3. That gets me x to the 9th. And then that means my next one is going to be x to the 5th. So you can see the pattern goes down by 4, and you can just follow the pattern. So that means my term number is 5, which means my k equals, hold on, means term 5 equals tk plus 1, which means my k equals 4. And again, I found the same information. Now you just work it through. So again, I really just like doing that. And the pattern is always going to be linear. So the minute you get to having this first difference, you can just go from there. You can just bounce it down. You don't have to keep working them all. I'll show this example again in the next question. We have some other examples where we don't know the k. Although in this case, it's easier to spot because there's only x's here, none here. So what I'm going to do is I'm going to figure this out to find my value of a. I'm going to go, well, I'm going to have 11, which is my n, c, k, I don't know what my k is. This is going to be x to the 11 minus k, and a to the k. Now, we don't know what k is, but I know this is going to be something, something, -4, 4, 5, 5, x, 8. So because I know that this has to be x to the 8, this also has to be 8. So 11 minus k equals 8. That means k equals 3. Hopefully you can see that, or I could add 3 and or add k. No, plus k plus k. So we get 11 minus 8 equals k, or k equals 3. So now that I know my k is 3, now I can just pop this in. 11c3 x to the 11 minus 3 a cubed is this thing. And now I can work this out. So 11c3 I need to do on my calculator. 11 math c3 is 165. This is going to be x to the 8 a cubed equals negative 4455 x to the 8. And I can cancel my x to the 8s. 165 a cubed is negative 4455. And now I just solve this like a math 10c equation almost. Well, close. I'm going to divide both by 160. Sorry, start off here. Negative 4455 divided by 165 gets me to that. So a cubed equals negative 27. Cube root that, math. Cube root of negative 27, and I get my negative 3. Remember, if this is an even power, okay, this was 4 or 6 or 8 or 2, you'd have to have a plus minus. You'd have 2 possible values. If it's odd, then it has to match the sign. Okay, last example. We're going to find the term independent of x. What the constant term, or the term independent of x, means is that the power I want on my x is x to the 0. That's my goal. I'm going to find the one that has x to the 0. So same thing we just did in the last example, except we're looking for a slightly different term. So this is going to be 8ck times 2x to the 8 minus k, and again I'll show you the algebraic as well as the McManus chart method, and 1 over x cubed to the k. Now, in this one, I'm just going to, again, solve this out using only the variables. So I'm going to take out the numbers and just go x to the 8 minus k times 1 over x cubed to the k, which means I have x to the 8 minus k over x to the 3k, which means x to the 8 minus 4k, right, when I subtract my exponents. 8 minus k minus 3k is 8 minus 4k, but that all has to equal x to the 0, because that's the exponent that I'm trying to hit. Now I do my sub-equation. 8 minus 4k equals 0, and k equals 2. Once I've done that, all the hard work's done. Now I just put this into here. 8c2. 2x to the 8 minus 2, which is 6. 1 over x cubed to the 2. And then that's what breaks this down. So 8c2, 28. 2 to the 6th is 64, and then I get x to the 6 over x to the 6. So 28 times 64 is 1792. So apparently my final answer is 1792. Bada bing.